Hi friends, today I am going to discuss about the linear regression and regression the data representation. So linear regression. So here in my previous lecture I already discussed clearly about this linear regression. But anyhow here I'm giving some kind of basic important points related to linear regression. So this kind of topics will be helpful for understanding the upcoming topics like ridge regression, lasso regression, and elastic net regression. So before going to understand these different types of the regression like lasso, ridge, so you have to understand these topics clearly. So the simplest form of the regression is the linear regression. So which assumes the predictors. So predictors is nothing but the input variables. Input variables like x1, x2, x3 like that. So this input variable, the predictors have the linear relationship with this target variable. So the linear regression it tends to establish the relationship between this dependent variable y and one or more independent variables. So if it is single variable, we have to consider a single x. For example, y is equal to wx plus b. So this is a single input feature. So this multivariable means w1 x1 plus w2 x2 plus w3 x3 plus b. So we have to try to establish a relationship between these input variables x1, x2, x3 and the target variable y. So for finding the best fit line through the straight line. So the equation of the linear regression, the equation of the linear model is y is equal to wx plus b. So generally, if you when you reading some kind of textbooks, you can observe a linear equation y is equal to mx plus b. So y is equal to mx plus b. In some notations, you can say like y is equal to wx plus b, or some notations y is equal to beta naught plus beta 1 x. So all kind of notations are be same, but don't be confused. So here in our equation, in our lecture, I'm taking this equation y is equal to wx plus b. Here w is nothing but this slope and b is nothing but the intercept. So this is the linear regression equation, w1 x1 plus w2 x2 plus w3 x3 up to wn xn plus p. So which means they are the number of input features from 1 to n. So these are the input features, and w1, w2, w3 these are the coefficients, and the b is the intercept. So intercept of this model. So in this equation, so in the linear equation, y is equal to wx plus b. So w and b, these are the parameters of this model. So these parameters are selected through this method, OLS method, ordinary least square method. So this method works by minimizing the sum of the squares of the residuals. So what is mean by sum of the squares of the residuals? So which means there is a difference between actual value and the predicted value. So actual values you can consider as the target variable y, and the predicted value you can suppose to consider y hat. So here if you observe this diagram, so this is the x and this is the y. So here this is the blue dots are the these blue dots are the our actual values. So actual values means you can consider as our target variable y, and this straight line is the red line is nothing but the our best fit line. So the best fit line passes through the sum of the data points, but not all the data points. So here uh, the best so many lines will be distributed through all the target variables. So among the so many lines, we have to identify the best fit line with the help of gradient descent algorithm. So GDA. So this is the concept I was explained clearly in my previous lecture, lecture number 4. So by using this gradient descent algorithm, we have to identify the best fit line. So the best fit line has give the best parameters like W and B. This is the best parameters, best minimum values is given by this best fit line. But this best fit line not passes through all the data points. So there is no straight line passes through all the data points. So what we have to do? The objective here is to fit the best fit line in straight line that will try to minimize this error. So here what is mean by error? So error means we can say that this is the blue point is one kind of a point. So this is the y and this is the point on the target variable y hat. So there is a difference is nothing but the error. So which means there is actual value y and the predicted value y hat. There is a difference means error. So this error means y I and y hat. So which means the sum of this squares of the so this is the sum is sigma is equal to 1 to n means number of observations and square. So this is called the error. So this error we have to be minimized. So this is the our objective. So the objective is to fit the best fit line, and the best fit line will try to minimize the error between this actual values y and predicted values y hat. So the extension to this linear regression invoking by adding this some kind of topic, some kind of thing is called the penalties. So penalties is this loss function. So there is some kind of loss function. So this kind of loss function we are supposed to add some kind of penalty. So what is the penalty? So if you add to penalty to this loss function, you can cut this some kind of algorithm. That algorithm is like ridge regression, lasso regression, elastic net regression. So these topics I will explain next lecture. So for loss function, this is the loss function. You are supposed to do some kind of penalty. This concept is called the regularized linear regression, or used to call the penalized linear regressions. So next, so OLS states model. So what is mean by OLS states model? So OLS is a ordinary least square method. It is a states model. So with the help of this model, we have to identify the more significant features. So more significant features has to be influence on the target variable y. For example, we have to take the x1, x2, x3 and x4, and this is the target variable y. So among these, here there the input variables is 4 and the target variable 1, total 5. So among the 4 input features, which feature has to be more important? Which feature has to be make a role on predicting the target variable? So we have to identify this which feature is important with the help of this method, OLS method. So for identifying the best input feature, we supposed to apply the p-value. So this p-value play a key role for rejecting the null hypothesis. So here null hypothesis state that the features that has to be zero significance on the target variable. So the feature has to be not make a more impact on the target variable. We have to be reject this feature. So which means the feature if the p-value of is less than 0.05. For example, I'm taking the x1 is the x1 p-value 0.01 and x2 p-value 0.02 and x3 p-value 0.91 and x4 p-value 0.20. So here 0.10 is less than 0.05. So we have to consider this feature. So 0.05, so we have to consider. So this is greater than 0.05. So x3 we are not considering for representing the third variable. So x.20 is also be greater than 0.05. So x4 also we are not considering. So we have to considering these two features x1, x2 for predicting the target variable. So the main objective of creating the model means we have to make sure that fit the data properly and reduce this loss. So which means that we have to take the model. That model is trained well on training data getting less error. So getting the on the less error on trained data. So the trained model is to be applied on the test data, getting more error, getting more error. So it means at that time, while during the testing, the model has to be fail and give the poor performance. So means while training, getting more error. Sorry, while training, getting the less error. While testing, getting the more error. So this kind of situation is called the overfitting. Overfitting. So this overfitting can be overcome with the help of these regularizations. So to overcome this problem, so we're supposed to do the regularizations. So regularizations means we have to penalize the coefficients. So the coefficients like W1, W2, W3. So these are the coefficients have, if it is maximum means more coefficients means values are more. So we have to be penalized. So at that time you have to reduce the error. For reducing the error means doing penalization, we have to apply some kind of regularization algorithms like ridge regression, lasso regression, and elastic net regressions. So by applying this kind of regularization algorithms, you can supposed to be overcome the overfitting problem. And data, now we have to see the data representations, how our data will be represented in regression. Regression, regression data presentation. Try to understand these topics, then only can understand upcoming videos. So here I'm taking the x. So this is my x. So here I'm taking the observations. So I'm taking the I values. So here nothing but the data points. So here this is the data points. So data points starting from 0, sorry, not 0, starting from 1 onwards, 1, 2, 3 up to n. So this is the I value starting from 1, I value 2, I value 3 up to n. And next here I am taking this is the features in nothing but the columns. So here considering the j, so starting from 0, 1, 2 up to m. So here I'm taking the 0, and this is the 1, and this is the 2, and this is the t. So which means here I means number of observations. So number of observations you can suppose to call I is equal to 1, 2 up to n. So it means length n observations, and j means number of columns, or you can use to call input variables or the features. So starting from j value 0, 1, 2 up to m. So which means 0 to m means 0 to m means the length is equal to m plus 1. For example, here from 0 to 3, which means uh, here, so j value will be 3 plus 1 means 4. So means here. So if you see, I can write this observation. So this is the x. So here x first row, 0th column, x first row, first column, x12, x13, and x20, x30, and this is the x23. Similarly, you can write x nth row, 0th column, and x nth row and m column, and this is the x, and I can say this is my target variable. This is the target variable. So y. So here this is my y naught, y naught up to yn, and this is my predicted variable. So y hat. So here I am writing the up to n observations yn hat. This is y1 hat. So here y1, y2 up to here y1, y2 hat, like that. And now this is my coefficients. So coefficient w0, w1 up to wm. So here how many features are there? M features. So that's why we have to take the m features. Suppose if you write an equation like y is equal to wx plus b, so which means you can take the w, you can get multiplied here. So this is the multiplied, w0 is multiplied with this one, and this one is multiplied with this one, like that. So here the predicted outcome, of any data point is I, is, you can write like this: yi hat sigma j is equal to 0 to m wj multiplied with this xij. For example, I am taking 0 to m value 3. Suppose w0 x first observations, 0th column, plus w1, and 0 means w1 x11 plus w2 x12, like that. So it means here w to 0 means this is the kind of index, this value is multiplied with this value, like that. So it is the simply the weighted sum of the each data points. It is simply the weighted sum of each data point with coefficients, so these are called the coefficients. So these coefficients is considered as the weights. So the predictions can be achieved by finding the optimum value of the weights. So the predictions can be achieved by finding optimum value. So optimum values of the weights. So weights means w1, w0, w1, w2. So these weights we have to be find the optimum values based on some kind of criteria. So it depends upon the regression algorithm. So means here the regression algorithms make a key role. Here x and y. So this is my training data. So training data is like that. and this is my test data. This is my training data and this is my test data. So this data will be scattered is called the test data, and this is the data will be scattered training data. So while training the model, so I'm getting the less error. Why? Because so y and so the points are the y and these are the y hat. So y hat, so there is the less error, less error on the training data. So this is my y and this is my y hat. So while during testing, so I'm getting the more error. So while training getting the less error, while testing getting the more error. So training error is less and testing error is more. So this kind of situation is called the overfitting. This kind of situation is called overfitting. Suppose the training error is more and testing error is also be more. So at that time we used to call the underfitting. Underfitting. So training error, testing error both are high, is called underfitting, and the training error is less and testing error is more, is called overfitting. So we have to create the generalized model. We have to create the so generalized. So generalized model means we have to create the generalized model means we have to create the good model. So good model means how can you say this good model? Less bias. So less bias means low bias and the low variance. So which means the train error less and the testing error less. So both training error, testing error less, we used to call it generalized model. So for getting a generalized model, what we supposed to do? We have to supposed to the minimize the error. So minimize the error means minimize the cost function. So how to minimize this cost function? So what is meant by cost function? So the cost function, you can say that this is the cost function. You can say sigma I is equal to 1 to n 1 to n. So yi minus y hat. Okay, this is the cost function. So the objective function is called the cost function. So the cost function we have to be minimized. The cost function has to be minimized. So minimized means we have to do the RSS. So RSS means residual sum square. So this is called the RSS. So residual sum square. So sum of the squares of the this is sum is sigma. Sum of the squares of the predicted values as compared to the actual values. So that is nothing but the cost function. So the cost function can be simply defined like sum of the square errors of the predicted value. So predicted value can say that y hat and actual value. So actual value can say that yi. So it means the sum of the squares of the predicted values. So we can say that yi minus y hat whole square sigma I is equal to 1 to n. So this kind of cost function we have to be reduced. So here the y hat means so we can say that sigma j is equal to 0 to m w j and xij. So xij means so we can write like this cost cost of W, so which means sigma I is equal to 1 to n yi minus y hat whole square, and sigma I is equal to 1 to n yi. So in place of y hat whole square, can I write like sigma j is equal to 0 to m and w j multiplied with xi j whole square. So this is the cost of w. So this is the linear regression cost function. For linear regression cost function, we have to be how to minimize. So what you can do, you have to apply the regularizations. So regularizations means to, you can say this cost function, and you have to add some kind of penalty. So penalty means if you apply the uh, L1 penalty and L2 penalty to this cost function. So this is the cost function. So in next lectures, the main questions will be based on this kind of equation. So here the cost function is equal to sigma equal to 1 to n. So n means here number of observations and m means number of the features. So wj means this is w is the our uh, coefficient of the search j, and x is our input feature. See the ith observation, so jth ka. So this kind of cost functions you can get in a linear regression. So in next lectures, I will explain about the regularizations like lasso and ridge and elastic net, enet. So this is the topic of the simple linear regression. So I hope you understand these topics well. If you kind of any doubts, please make it in comment section. Thank you.